Okay, so in today's lab, we are going to be doing 3 different reactions and then trying to see how do their delta H's add up. Because according to Hess's law, if you can add equations together, then their delta H's, their heats of reaction, will also add together. So we're going to try to verify this and just kind of see how accurate we can be on this and kind of just go from there. So these are the 3 equations. We're going to take some solid sodium hydroxide, just put it into normal water, and the sodium hydroxide is going to dissolve. But we know any ionic compound, when it dissolves as ions. So it's going to be aqueous sodium, it's aqueous hydroxide ion. We're going to measure the heat released when that occurs. The second experiment is going to take solid sodium hydroxide, but instead of putting it into water, we're going to put it into hydrochloric acid. Now, hydrochloric acid is a strong acid. That means it's going to be 100% dissociated as H plus and Cl minus in the solution. It's going to react to a neutralization reaction, make water, but the salt's going to stay dissolved, so it's going to be dissociated, Na plus and Cl minus. Again, we're going to calculate the delta H of that reaction. And then lastly, we're going to take an aqueous solution of sodium hydroxide, so the ions are already dissociated here, with an aqueous solution of HCl, and do the exact same reaction here, but instead of being solid, it's already dissociated in water. We're going to measure the change in heat there. Now, the pre-lab of this lab, for this lab, says to find 2 equations that add together to get the overall, to get us the third equation, okay? Without rearranging any of these, if we look at equation 1 and equation 3, you can see that the NAs cancel out, the OH minuses cancel out. So when we combine 1 and 3, NaOH plus H plus Cl minus makes water plus Na plus and Cl minus. That's the exact same as this equation. So really we should say that equation 1 plus equation 3 equals equation 2. All right? Which means that delta H1 plus delta H3 ought to equal delta H2. That's the whole goal, to see, is that true or not? So, in order to do that, we're going to be using a coffee cup calorimeter. Okay, and this is going to be our setup right here. Okay, so here's the coffee cup calorimeter. It's nothing but a styrofoam cup in a beaker. Okay, so first thing that we need to do is we need to measure the mass of the styrofoam cup individually. So the mass of the styrofoam cup is equal to 3.47 grams. Okay, right there, 3.46 grams. I don't keep saying degrees, grams. Okay, so now we're going to do the reaction. First thing that has to happen, it's got to measure out 100 milliliters of water into a graduated cylinder. Now the directions in this lab to say just to use the density of the water, but we're going to measure the mass of the solution at the end. So I'm going to get exactly 100 milliliters of water. Use my little squirt. Exactly 100 milliliters. And because, again on this, because the individual unit is equal to ones, we're going to measure to the tenths place. So this is going to be 100.0 milliliters. So I'm going to put that into my styrofoam cup, into my calorimeter. Okay, so I used 100 milliliters of water. Okay, and it's in my calorimeter. Now, I'm going to take a lab quest, and I'm going to use the temperature probe, and I'm just going to get the temperature of this solution. This is going to be my initial temperature. the initial temperature of the solution. Okay? It's stabilizing. Looks like it's 20.5 degrees. 20.5 degrees is the initial temperature of the water. I now need to measure out approximately 2 grams. 2 grams of NaOH. Now, NaOH is what we call hygroscopic. It does absorb. Oh, that's too much. Take out a big chunk. All right, now let's see, no, there's not a little piece in there. Okay, so I'm at 2.14 grams. So we're gonna leave it at that, 2.14 grams. So hopefully again, you can see that, 2.14 grams. So that's the mass of the NaOH. So now we're gonna take that, we're at 20.5 degrees, take this, put it into the water, and then just stir continuously until it all dissolves. Now the temperature is going up. Let's see if I can make that stay. Doesn't look like it. There we go. See if we can you see the, crud. .1, hopefully you can see that. It's just going up in temperature. It still hasn't all completely dissolved yet. Okay, so we'll just see the temperature is still kind of going up, 24.1, 24.2. Still going up. This is the longest part. Okay, so 25.5 looks like it's the final temperature. Okay. I don't want it to lose it again. Okay, so 25.5 degrees. I'm not sure if I touch on this, it's going to want to change it back. Okay. 25.5 degrees. That's your final temperature. So we have the initial temperature, we have the final temperature, okay? Now the last thing that we need to do for this part is we want to get the mass of the solution. Rather than using the density of the water and whatever, we can just go ahead and get the overall mass of the solution, zero this out, and then put our styrofoam cup on there with the solution. And so now we know that the mass of the solution is 103.75 grams. So all of that information needs to be recorded into a lab report, okay? So that is reaction one. Once we have that, we can now dump this. We want to use the same styrofoam cup, rinse it out with water, just dry it so we don't have any extra water in there, okay? And now this time, we're gonna do the exact same reaction, but we're gonna do the reaction this time with 0.5 molar HCl. So I'm gonna use 100 milliliters of the 0.5 molar. So I'm gonna go and I'm gonna add 100 milliliters. Okay, so I have the bottom of the meniscus right on the top of that line. It's right there. So we're right at 100. I'm gonna pour this into here again, into my calorimeter, and put the thermometer in here. Now again, to measure to see what the temperature is. Okay, so now you can see, we'll see here in a second, you should be able to see, temperature is 21.1 degrees, okay? That looks like that's gonna be my initial temperature, 21.1 degrees. So now I need to weigh out another 2 grams of sodium hydroxide. So I'm gonna use my weigh boat. Zero it out. Just add in my 2 grams. 1.65. Okay, so there's 2.13 grams. 2.13 grams again. Okay, so that's for reaction 2, that's the mass of the sodium hydroxide. So now, again, I'm going to put that into, add that to my HCl now. Now we want to measure what is the highest temperature. What's the temperature going to come up to? Okay, so we're going to stir it until it's all dissolved, till the temperature stops going up. It's going up, going up, going up. 25.8, 26.3, 26.5. Okay, 29.7, 29, 30.2. Still going up, 30.6. Having to stir continuously because we want the water heated evenly. There's still a little sodium hydroxide left undissolved. So it's still going up, 32.2. It's almost all dissolved. Let's see if it's going to go up 32. There, it's still going up. So we want to record the highest temperature. think we're just about there. Looks like 32.7 might be our winner. Doesn't look like it's going to go any higher than that. So our final temperature is 32.7 degrees. Okay, so you record that as your final temperature, 32.7 degrees. Okay, so that's reaction 2, but now we still need the mass of our solution. Okay, so make that go back to 0. Take out my temperature probe. I'm going to put this onto here now. And so my mass of my solution is 104.14 grams. 104.14 grams. So that's the end of reaction 2. Again, rinse it out. This is just salt water now. Do a quick dry. Okay. So now for reaction 3, we're going to use 50 milliliters of acid and 50 milliliters of aqueous base. So I'm going to use the same graduated cylinder for the acid, but this time it's 1 molar. The first time, previously it's been the 0.5 molar HCl, and that needs to be in your data table as well. So the fact that on reaction 2, we use 0.5 molar HCl. In reaction 3, we're using 1 molar HCl, but only 50 milliliters. So I'm going to fill this up to 50. Okay, there's 50. I'm going to pour it into here, into my calorimeter. And I'm going to let the temperature start stabilizing out, figuring out what my initial temperature is going to be. Now, I need 50 milliliters of 1 molar NaOH, sodium hydroxide. Take 50 milliliters of it. Again, it's going to be 50.0 because we're measuring in the graduated cylinder. We can go to 1 decimal place. All right, so now before I mix it, I need to get my initial temperature of my solution. I need to get the initial temperature. I need to get the initial temperature. Did my battery just die? Okay, we only need a little bit left, so come on thing, hang in there. I don't want that. Okay, so hopefully you can see the initial temperature is 21 degrees. 21 degrees, 21.0 degrees. So now I'm just going to add this one's much quicker, add the NaOH and stir it. The temperature is quickly going up, 26.5. And 26.7, oh there it goes to 8. I think 26.8 might be it, because you don't have anything to dissolve yet. 26.8 will be your highest temperature, 26.8. That'll be your final temperature for reaction 3. Now again, I need to get the mass of my solution. So I'm going to get the styrofoam cup again, and we can see that the mass of the solution is 103.91. 103.91 grams. So that's all of the data that you need for this lab. Okay, so you need to record anything that got measured. You need to have that down in a neat, organized data table. Reaction 1, all the data. Reaction 2, reaction 3. Label all that data clearly and concisely. Okay, labeling everything, making sure to include the concentrations of your solutions. Okay? Will be a part 2 to this video where we're in class and we kind of talk about the calculations that need to be done. But you need to have, all virtual students need to have the complete data table with all of this on here. The title of the lab is the additivity of heats of reaction, or Hess's law. And the purpose is to verify that the heats of reaction are summative. Okay? So that's your purpose. So you have a title at the top, then you have a purpose to verify that the heats of a reaction are summative. In other words, they add together. All right? And then just with your, then data comes right after your title and your purpose. All right. Look forward to part 2 of this.